All right, so we're going to do the write-up of our exclamation points. So if we remember, here's our code. You guys all did this write-up. I'm still in the process of grading that, but I'm going to show you what my answers might have looked like so that you have kind of a reference point on what it should look like, essentially. So here's our code. Our overall purpose for our program, that's part 3A. Also in part A would be our description of the video, but our write-up that we did not have that section, so I'm going to skip that for the time being. So our overall purpose, this program is designed, I can spell, is designed to take a user input, then transform all of the I characters into exclamation point characters. The result should be printed out. So, or I guess the result will be printed out. So, very simple description. We're just saying, what is the overall goal of our program? What is the point of having made this? So for some of those examples we watched earlier, we could say that the goal of the program was to drive around a car and collect orbs, or move around a rectangle and collect boxes, something like that. So 3A, pretty simple. Just doing a description. What is our code for? What is the program we've written for? Section 3B. This is the list section. This is determining whether you know how a list is being used, whether you're using a list, how it's, or what you're using it for, all that fun jazz. So in 3B section 1, our first program code segment must show how data is being stored in the list. So if we look at our exclamation points code, I am storing data in a list on just this line. This is where I'm shoving data into a list. So I would copy that to here. Text list equals list of text. I'm making my list to store that data. Our second code segment must show how the data in that list is being used and any of that stuff. So how are we using the data in the list? And that's all happening in the rest of the code in the function. So I can copy that, paste it there. We're looping over each letter and index in our text list. If the letter is I, we replace the index with exclamation point. And that should, there. Nope. Okay. And then we are going to provide a written response that does all three of these things. We're identifying the name of the list being used in this response. The name of the list in the name of the list is text_list. The data in this list is each character in the user input string. I can word this better. Each character in the user input string is split into its own element within the list. So our list is storing each character in the user input string. So, and then, so that's the 3 and 4. And then 5, we need to explain how the selected list manages complexity in your program code by explaining why your code could not be written or how it would be written differently if you did not use a list. So in our code, we're using a list because lists are mutable where strings are immutable. We're able to easily edit individual elements within a list where we can't do the same with strings. So in this program, a list is being used to manage complexity because lists in Python are mutable where strings are not. Since we are replacing letters in a word, doing this with a string would require much more code, much more complex code, where it is very simple to do so with a list. So we're describing why a list is helpful for our code. So in my program, this whole loop would be much, much more difficult if I needed to use a string. I would need to do slicing. I would need to grab from like 0 up until the current index plus something else plus the rest. And that's way more processing that I would have to do than if I just turn it into a list and then change every element individually. So using lists makes this process easier, is how we're managing complexity. All right, that's section 3B. That's our list section. 3C is the function/algorithm section. We are gonna, in 3C1, we need to capture the code segment that is a student-developed procedure. So if you remember, procedure and function are synonyms. So we need to find a function that we, as the student, have defined in our program. So if we look at the entire thing, the function that we defined is that entire exclamation function. So I can copy that, paste it right here, and boom, our function exists. And our second program code segment must show where your student developed procedure, so where the function that we just pasted, where it is being called in our program. So where am I calling exclamation? So that's happening down here. And let's change the font on this to Courier New. All right, so we're saying this is our words, and we're printing our exclamation of words. So we're calling our exclamation function in this area. Then we're going to provide a written response that does both of these things. We need to describe in general what the identified procedure does and how it contributes to the overall functionality of the program. The exclamation function makes up the bulk of the functionality in the program, since it is the function that takes a string parameter and replaces all of the I characters with exclamation point characters. This function will then return the edited string. So describing what our function does. Obviously, if your code is more complex than literally just the one function, you'd probably describe a small subsection of the code that you wrote rather than pretty much the entire thing. Now, section 4, describe in detailed steps how the algorithm implemented in the identified procedure works. Your explanation must be detailed enough for someone else to recreate it. So you want to make sure that your explanation is clear, and they want to make sure that you know how sequencing, selection, and iteration work. So remember, sequencing is things happening in order, selection is making a choice, and iteration is looping. So you don't have to say exactly how you implement things, but your description should show people, or should someone reading it, should be able to write code to do what you did. So the very first thing we do, the string parameter is converted to a list and saved into a variable. So that's the very first thing that happens in our algorithm. Now, using words like first and next and then, things like that are going to show we have a sequence, we have things that are happening in a very specific order. So I would recommend including words like that, words that are going to demonstrate I know that there is an order. I know that there is a sequence to my algorithm. So first, our string parameter is converted into a list and saved into a variable. Next, the list is iterated over. We are looping over the list using a for loop. So we're iterating over our list. Using the word iterating is definitely going to be a tell to someone reading, saying, hey, I know that they know that we're using a loop, that we are using iteration. Each time through the loop, the current letter is compared to the letter I. If they match, then the element at that index is replaced with an exclamation point character. Otherwise, nothing happens. So here we are showing that selection is happening. We are doing a comparison, and we have an if they match, then something happens. We're showing that our program is making a decision. And then after the loop is over, the list is joined back into a string and returned. And that value is returned. All right, so there is my whole description of how this algorithm works. If you were to read this, do you think you could build this algorithm yourself? Is that a fairly clear explanation of how this whole thing works? That's the goal of this section. I think as long as you're being clear, as long as you're showing you know that things have to happen in a specific order, as long as you show that there is a loop happening, there is some kind of iteration, as long as you show that there is selection happening, you're making a decision, you're going to get the point for this section. So just be aware that you're just describing how your algorithm works in the English language. You don't have to have any code. You don't even have to have specific details. I'm not saying that I am using an enumerate. I'm not saying exactly how any of this works. So if someone isn't familiar with Python, they might do this in a different language. They could probably implement this in a different language. So there is section 3C4. So that's how that's supposed to work. And our final section is 3D. 3D is proving that you know how to test the function that you just talked about. So when it's asking for different calls to the procedure identified in response 3C, you are going to essentially make up different function calls, so different parameters that you could pass to your function that you described that would cause some different thing to happen, some different output to occur. So if we are replacing lowercase i's, what could our first call be? If we were trying to test that this function works, let's say our function call is exclamation with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 i's. So there is our first call to my function. I am identifying a parameter that would produce a specific kind of output. What are we testing in this function call? We're testing what happens in the algorithm when all of the characters in the string are an I. So here we're performing a test to see what would be output, making sure that we know how it works, making sure that we know that it works. So our results from this call, the function would return the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this scenario. So knowing what value would be output from our function, what's going to be returned, that is the result of the first call. We would return the string with a whole bunch of exclamation points because that's what our algorithm is designed to do. So our second test, let's say we want to test what happens when we have none of the letter I. So let's fill in that section actually first. What happens in the algorithm when none of the characters are I? So our call could be exclamation with I like, no, I eat apples. So in that string, there are no lowercase i's. So obviously, there's nothing to replace. So we're testing what happens when there's nothing to replace. So in this scenario, the function would return the string I eat apples, as there are no I characters to replace. All right. So do all of my answers in this section make sense? Does this clarify what the performance task is asking me to do. Okay, so I hope this was helpful. I'll be posting the recording of this. I can stop recording now.